simple and straightforward. It simply says that you are given three colors, red, white, or blue. Now they are actually numbered as 0, 1, or 2. You have to sort them. So it is indirectly saying you are given an array of n elements, in which elements are only 0, 1, or 2, and you have to sort them. Now the fact or the main prime thing is you have to sort in place. In place means without using extra space. Now again you have to return the sorted array: 0, then 1, then 2. As you can see, 0, then 1, then 2. This is your answer. Now if you see very closely, how will your final answer look like? Final answer will have 0, then 1, and then 2, something of this fashion. Now if I if let's say let's say imagine you are a child, I would have given you 3 balls of different, like I've given you 3 colors, many balls, and I asked you to separate them. I'm not saying to sort them, I'm asking you to just separate these different color, three different color balls. You should separate them. I give you 100 balls and asked them, please bro, can you separate it? Then as a child, what you will do, you will put one kind of ball together, and the third kind of ball will automatically be together. That is what is the actual crux of this problem, that we know we want to get all the zeros together, we want to get all the twos together. Now if we will bring all the zeros and twos together, ultimately one will automatically come together, which means I just have to make sure from the end all these are zeros, from the left end all these should be zeros, from the right end all these should be twos. If that is the case, I'm good. Ultimately in the middle they will be ones. Now for sure, as we have to make things from end, left and right end, we know that we can maybe think of some sort of 2 pointers. Now in 2 pointers we have already seen in the crash course. If you're not watching, just go and watch it. So we have 2 pointers with sliding window which follow this kind of pattern. Now in this, there's no sliding window as such. It's more of same as trapping rainwater kind of problem. Again, if you have not watched it, just go and write problem name by my name, you'll get the video. Now coming on back, it's simply 2 pointers. We are just trying to imagine. Right now we are not sure if it work or not, if it will even work or not. So we're just imagining. For sure 2 pointers means start and end. If I have start and end, so it's just that okay, I have L and R pointer, and then I will do some sort of movement L and R, and then I should be able to get my answer. But how? Let's see. Let's try. So what all can be the case? For sure, we have now jumped on that we will try to think of in 2 pointer terms, because we have to build from the end. You have to build the array from the end. So let's think of in the 2 pointer terms. Now thinking of in 2 pointers, for sure, I have to take 2 pointers. So I have taken 2 pointers. Now, if I have taken 2 pointers, there are very few cases only. Okay, L can be 0, R can be 1. Again, so you will see I have taken the cases as 0, 1, 0, 2, 0, 0. Other cases 1, 0, 1, 1, 1, 2. Other cases 2, 0, 2, 1, and 2, 2. So these are the only possible cases for your L and R. Let's see how I will move my algorithm. So if I have my L and R, for sure, I know one thing, that L is 0 and I want it in the left, it should be 0. So I will move my L. Okay, let's try for something else. If my L is 0, R is 2. I want it in the right end, it should be 2. On the left end, it should be 0. Move both L and R. Okay. L is 0, R is 0. One thing is for sure, okay, L is 0, which is correct. So only move L. Okay, only move L. L is 1, R is 0. Ideally, nothing I can move, but I can swap it. If I would have swapped both my L and R, so at L, my 0 will come in, at R, 1 will come in, and now L is at the correct location. Now I can move my L. Okay, I can move my L. So I did first swapping to just bring in, because I realized both are at the incorrect location. I should have 0 on the left, on the right I should have 2. But even if not, I can go back to this case, right? Okay, even if I get a 0 in the left, I can still say, okay, I can increase my L. So just so as to move something, I did a swap and then move my L. Okay, what about both are ones? What you will do? You cannot swap. You cannot even move both L and R, because who will you move, L or R? If you move L, let's say if I would have moved L, bro, you lost its address. Like, you lost this person. How will you even replace it with someone? Like, for replacing it with someone, you need to know its address for sure, right? How will you replace it? You cannot. Okay, that's a big question mark how I will solve it. But okay, let's continue. What if I have a L and R? Okay, R is sorted, so decrease the R. What if I have L here, R0? Both are incorrect technically. Let's swap it. Okay, we swapped it. It became L as 0, R as 2. Now I'm good for both of them. So decrease both, like increase L, decrease R. Okay. Then L is 2, R is 1. Same way, I know both are incorrect kind of. So swap it. I'll get L as 1, R as 2. Now R as 2 is sorted. So decrease the R. And then ultimately L is 2, R is 2. Both are good, but okay. Sorry, like not L is good, but R is at least good. I can decrease my R. Everything was reducing my range. I was very good. It's just that one blunder came in picture when both are 1. Okay, which means I need to do some sort of stuff that like I realized one thing. I cannot work around my algorithm only by taking L and R. Because if I take only L and R and both L and R are at 1, I need to know someone who can replace this L and R. So as for to search for someone, I was not satisfied by 2 L and R indexes. So I tried to search for a new one. Okay, I thought let's take third index or third ID. Now it is not kind of a 3-pointer going towards, but still we saw the requirement. We need someone else. That's where we jumped onto. So now ID will be a third pointer. Now you will have confusion how and what pointer to move. So it's totally up to you how you want to move your pointers, because now you have 3 pointers. You have to move all 3 of them. Usually 2 is more than complex, but now it is 3. So how I will move it? Now it's evident that can't we just say right now at what point we were stuck? We were stuck when L was at 1, R was at 1, which means I will say that L and R will be the stuck points and ID will be the resolving point. What do you mean by resolving point, Aryan? So it means that ID can be a 0 or a 2. This will help me to resolve. Again, if it is a 2, it will help me resolve my R. If it is a 0, it will help me resolve my L. So that is how I reached to a conclusion that, okay, let's initialize everything. Let's go the same way I was doing earlier also. Same normal 2 pointers. It's just that now I have given a specific task. Okay, I was stuck at this task. ID, I know, okay, whenever it is a 0 or a 2, I should make sure I should replace it with the corresponding L or a R. And I know 0 should come at L, R should come at, sorry, my 2 should come at R. Now, for sure, the same way earlier I had only L and R initialized with 0 and n-1. Now I have ID also. From where to start? Obviously 0. So I'll start my ID also with 0. Now, let's see. For sure, I know the responsibility to bring some element at the corresponding location is of ID. So, okay, ID is 2. ID is 2. For sure, it should come at the end as in R. So I will come, it should come at the last, which means swap with R. So ID is this, R is this. No matter what R is, I am only concerned about ID, because ID is the candidate who will make sure what person will come in at the corresponding end, either L or R. Okay, ID was 2. So he told, okay, I need to come at the end. So he will swap with R. So this value will be swapped with R. Now what will become? Okay, it has reached to a correct location, and ID is at, okay, 0 only. Now you will say, Aryan, okay, that makes sense. Now when my nums of ID was 2 and I know I did a swap with R, so it's obviously for sure 100% sure that ID, like nums of R, will always be 2, right? If it is always 2 for sure, it makes sense. It is sorted, like it is correct. Decrease your R. So I will decrease my R. So again, remember every step. You did ID as 2. You saw that you have to swap with R. You swapped with R, and then you have to decrease your R because your R was correct. Now you might ask, Aryan, it feels evident you decreased your R, but it feels evident that you should also increase your ID because ID is also correct. I'll say yeah, makes sense. Ideally, ID is correct, so you should actually increase your ID. But then my question will be, what about the L? You will say, Aryan, L is 0. Let it remain at 0. Okay, but there's a few things which you will end up missing later on. I'll show you better, Aryan, but what I am saying is that, again, I'll prove everything later on, but my saying is that when I have swapped with my R, I should not increase my L. So I should not increase my ID. Why? Because ID should be more than or in like more than or equal to my L. If I will leave my L hanging, which means if I have moved my ID, then L will remain at 0. But I should make sure that L should actually be stuck at a location. L should be stuck at a location where from where he cannot move forward. No worries if you don't understand. Let's see. I'll prove everything later on. Cool. Now we realize, okay, I will not move my ID. I moved only my R. Okay. Now ID is 0. For sure, if ID is 0, he needs to come at L locations. So ID is 0. You can argue, Aryan, I will just simply move on both L and R. So you can simply move both L and R, or you can also say that I will swap my ID with my L and then move both L and R. Now you might say, Aryan, this step is redundant for this. Exactly, it is redundant. But still I showed you because this step can generalize if my ID is L, like is 0, or like even if I had L as not anything, still it would have helped me. No worries, I'll show you. But still you realize, okay, L and R, ID and L both will move. Okay, ID and L both move. Again, both are like ID is 0. So ID's responsibility is bring that thing to L. Okay, I will bring this 0 to L. Okay, it's already at L. No worries. Move both ID and L. Now, ID is 2. It should come at R. Simply, ID is 2. It should come at R. Same as step 1 we did. Swap it and then decrease your R. So firstly, I will swap it. You will see I had 1 and 2. I had a 2 and 1. I did a 1 and 2. I did a swap and then I will decrease my R. Okay, I'll decrease my R. But I told you ID will remain same. No worries, I'll prove it. Now, okay, ID remained here and my L is also here. Now, technically you might say, Aryan, the things seem sorted. So do I end here? How do I know I have to end here? Okay, another question came in. So right now you have two questions in your mind. Firstly, that Aryan, why did you not decrease your ID? Just tell that part. Sorry, why did you not increase your ID when you did a swap with R? That's the first question. Second question is that Aryan, when I should know that when to end? Or you can say third question also is that when I, like, from what I should start. Like earlier, if you remembered, I was starting with while L is less than R. The standard 2 pointers, while L is less than R. Usually we have this kind of 2 pointers, but what is this condition? Like how I should start here, because now I have 3 pointers. So okay, let's solve all these questions. Firstly, what should be the starting case? Usually you have a while again, while L is less than R, or while L is less than equal to R, or you can have while ID is less than equal to R, or ID is less than R. Now, considering there is like ambiguity between less than or less than equal to, so let's only sort out if it is L or ID, who should come in the while loop, right? We realize one thing, that my L will be stuck at a location and it will help. Again, you remember, my L will be stuck at a location. He will be a candidate for my ID. He will be a candidate. My L will be my candidate for my ID to tell, okay, ID has a value, come and go at this L. Like come and bring, like come at this L. Or ID will tell, okay, come and go at this R. So ID is the master. He will tell he should go at L or R. But L or R should be at the should be at the first stuck location. For L, the first stuck location is after zeros, or he can be at the 0 also. And for 2, its first stuck location is after 2's. Right? Now, you realized if that is the case, obviously L will be here, R is here, ID is moving. So ID will be close to R and ID will actually tend to cross R, because L will remain constant at this one only forever. But my ID will keep on moving forward. So I realized one thing for sure, that I have to make sure that while ID is less than R, or ID is less than equal to R, this is a condition which I should follow. Now, the case is, if we have realized while ID is less than R, like ID and R, we have a relation in the while loop, what should we write? ID is less than R or ID is less than equal to R? Again a question. Okay, no worries. Let's take the example. Every time you will do, you have to simply dry run, either by taking your own example or maybe something. You have to figure out when this can break, or this again, because this is more. So basically you have to prove that this will break. How? Let's see. Now this example will solve remaining 2 questions. The first question was this, that while ID is less than R or ID is less than equal to R, what I should choose. Second question which was remaining is that when we swapped with R, I should not increase my ID. That's a question number 2. Okay, this example will solve both of them. How? Let's see. In the very beginning, I have ID as 1, L as R. So technically ID is like value at ID is neither 2 nor 0. So he is not basically handling any value. ID is not handling any value right now, which it can give it to either index Z, index L or index R. So ideally ID has to move because ID will only contain the value which is 0 or 2. So as it can allot that value to either L or R. Okay, so ID moved. Now ID is at 2. If ID is at 2, he should go at, so if the ID value is 2, he should go at R. Okay, ID was 2. Step 1, we saw he should swap with R, and then my value, R value will become as 2, ID will become as 0. Now we saw that okay, nums of R will always contain a 2. If that is the case, for sure decrease the R. If I will decrease the R, how it will look like? It will look like that okay, R is here. And then if you would have increased your ID, remember you were saying that question was, shall I increase my ID or not? If you would have increased your ID, first thing is that your ID would have exceeded, already. Your ID would have exceeded already, and then this is not the correct state, and your program would have ended here, and this is incorrect. So one thing is for sure, I will not increase my ID. I will make my ID for sure here. But even if my ID is here, still I should run my for loop. Why? Because still I know that this L and ID should be swapped. So I realized that I should run my for loop while ID is less than equal to R. Still I should run my for loop. So this solves both the equation that why ID should not be incremented and why ID is less than equal to R. Cool. Now, but still last step is remaining. ID contains a value 0, which is a good candidate, for my location L. So I will swap with my L. ID is 0, I will swap with my L. How I will do it? Simply swap. After swapping, I will get a 0 at this location and 1 at this location. Now, for sure, L has the correct thing, so L will move. Okay, L will move. The question will be, Aryan, will ID also move? Will ID also move? I will say for sure yes. Now again, this is a question, why yes? So as to prove why yes, and again Aryan, why will the case which we saw while swapping with R, why will that case will not come here? It is because that if you have your ID, you know that you will for sure swap with swap with your L. Now we were okay because we saw that this L contained a value of 1, and then when this 1 will come here and 1 will come here and 0 will come here, for sure L will for sure move, but ID can also easily move because ID contains the value 1, because ID only needs a 0 or 2. ID can move. But then you will ask, Aryan, you were smart, you took 1 first to show, but what if it was 0 and a 2 here? If it was a 2 here, then after swapping you will say, Aryan, after swapping this will become a 0 and a 2, and ideally ID should stay at 2. That's the case. I will say, bro, this 2 and a 0 and ID being here will never even happen. Why? Because when your 2 was here, for sure ID randomly did not come at 0. ID would have scrolled from left. If ID would have gone from left, so for sure ID would have come on the left also. When ID found a 2 on the left, it was not standing. It made sure that this should go in the end. Thus, I always made sure from the left that 2 always kept on going in the end. Thus, this condition will never even occur. I will have only 1 or a 0 in the left. And that is the case. I can safely increase my ID also. That is the proof for everything. Now, if we just do a summarization, we realize that we will have firstly condition that ID is related to R. Then we realize that ID should be less than equal to R. Then we saw that, okay, if my nums of ID is 0, then I should swap with my L. And I also showed that, okay, it is always safe to increase your L, and it is always safe to decrease your R whenever you get your ID as, this is ID should be as 2. Again, do a swap and decrease your R. It's always same. But in the case when I am doing with ID, it is also safe to increase your ID, and we saw the proof. And ultimately, if it is 1, Simply increase ID because ID should only store a 0 or a 2. And thus, this is the code. Simple. So this is the exact code which I showed you, that my L, R and ID, right? And time, as we can simply see, it is O of n. Space will be O of 1 because of no extra schedule. It's just simply a 3-point approach. Cool. I hope you got it. Bye bye. Take care. And again, 45K करवा देना यार before June. Bye bye. Take care. Discord join कर लेना.